In this section, we're going to look at some mathematical properties, namely the associative, commutative, and the distributive property, along with the identity properties. We're going to look at how we can justify the steps that we do when we're simplifying. So first off, property definition. It's an essential or distinctive attribute or quality of a thing. Mathematical properties are usually statements of truth that we use when we do mathematics. So press pause for a moment, and I want you to try and fill in all of these blanks here. What number is missing from each of these to keep the two sides equal? I hope that you didn't find that too difficult. It's simply the numbers that were missing from the other side. And I want you to look at these 6 problems and think about what was done on the left side compared to the right side. How are they different? And I want you to try to think about what you think this commutative property is. All 6 of these are examples of the commutative property in action. And what it says is when you're adding or multiplying, the order of the numbers does not matter. When people commute to work, they're moving from one place to another. The commutative property is about moving the terms within an expression and keeping the value the same. But this is only for adding and multiplying. I want you to pause the video again and once more try to fill in these blanks and decide what's missing. Again, the thing that was missing is the number or letter that was missing from the left-hand side. And these are all examples of the associative property. And once again, pause and try to decide what's happening, what's being done from left side to right side that's keeping everything equivalent. And what the associative property says is that multiplication and addition can be performed regardless of how numbers are grouped. And one thing to think about to help you remember this is that when you associate with people, you join different groups. This property is about grouping. It's also saying that it doesn't matter if you have a bunch of addition or subtraction. It does not matter which one of the additions or multiplications are done first. So you're going to have to be able to identify the properties. And here are 4 examples. Pause the video. Decide whether each one of these is commutative or associative. The first one, we weren't regrouping, we were reordering the addition. That is the commutative property. The second one, we are regrouping. That's the associative. Third one, associative, we're regrouping again. And the fourth one is commutative. One thing to note is that the first 2 are the commutative and associative properties of addition, and the third and fourth are the associative and commutative properties of multiplication. They say slightly different things, but what they mean is the same. So I want you to do a little bit of arithmetic here for me. I want you to think about what goes in these blanks here. 5 plus 0, I hope you all know that's 5, and 5 times 1, I hope you know that is also 5. And these 2 statements are examples of the identity property of multiplication and addition. And the identity property of addition is this first one. The identity property of multiplication was the second one. So what does the identity property say? It's all about adding 0 and 1, or adding 0 and multiplying by 1. So what the identity property says is it tells us what we can do that does not change the value of an expression, because adding 0 doesn't change the value of the expression. Multiplying by 1 doesn't change the value of the expression. And this identity property of multiplication is something that you've been using for a very long time. Every time you change the denominator of a fraction, when you multiply the top and bottom, say by 3, what you're really doing is you're multiplying by 1. You're not changing the value, you're just changing the way that it looks. So what number is always used in the addition identity problems. What are we adding to not change anything? We're adding 0. We call 0 the additive identity. And the number that's always used in the multiplication identity problems is the number 1, and the number 1 is the multiplicative identity. Our last property is the distributive property, and the distributive property passes out multiplication over addition and, I guess, subtraction. The algebraic representation of it is that we take a times a sum, b plus c, and what this property says that we do is we take that number outside, the a, and we multiply by both things on the inside. We do a times b plus a times c. Similarly, distributing over subtraction, a times b minus a times c. To illustrate this, I'm going to find the area of a rectangle. That's 2 by 7. What's the area? I hope you guys all know that this area is 14, 2 times 7. But there's other ways that we could look at this. We could break this rectangle into 2 small rectangles where we have a length of 4 and a length of 3. This would be this, finding this area as 2 smaller pieces would work just fine. We would do 2 times 4 plus 2 times 3. And this is equal to 2 times 4 plus 3, the 4 plus 3 being the original 7. That's what these two versions of the distributive property over here are showing us. We're taking the a times each piece inside here, a times b, a times c, and then adding them together to find the total sum. And if we're thinking of it as an area, I think that makes a lot of sense. So we have 4 examples down on the bottom. Pause the video and give it a try. If you have no idea what to do, just keep going, keep rolling with me here. But once you kind of get the gist of it, give it a try and see what you can do. So we're doing 2 times x, which is 2x, and we're doing 2 times 3, which is 6, and we're adding the 6. The next one. The negative outside is really a negative 1, and that is what we're distributing. Negative 1 times 4, negative 4. Negative 1 times negative y, positive y. Now, for the next one, I'm going to do this using a rectangle model. We can think of this as being a rectangle that has areas, or has sides of negative 3m and m minus 5. Doing this allows us to find area instead of this abstract distributing thing. So what's the area of the leftmost box? Well, it's negative 3m squared. And the rightmost box is going to be positive 15m. So there's our distributed answer, negative 3m squared. The last one, I'll do that using a box again. 1/2 and 2n plus 6. 1/2 times 2n is 1n, and 1/2 times 6 is positive 3. So this is equal to n plus 3. If you're comfortable doing this without the rectangles, plow ahead and go at it. the rectangles can really help you keep organized with your thinking and your working, if it's something that you're struggling with. And the last three things we're going to look at is identifying properties as they're being used throughout a problem. So what we have here are two examples. There's one on the top, one on the bottom, and we need to identify what properties are being used. So in the top, what happened? Did we change the order or did we change the grouping? Well, in the parentheses we changed the order, so that is the commutative property of addition. And you should get in the habit of specifying that it's for addition. And then in the second one, it's the associative property of addition. And then we finish off getting 17 plus x by adding the 4 and the 13. In the second example, we have 6 times the sum x plus 7, and then it's rewritten as 6 times x plus 6 times 7, and recognize that as the distributive property. So these last two have a few more steps than we just saw. I'd like you to pause the video and try to justify each one of these. So this first step that we did is the commutative property of addition. Because we have changed the order of the terms in this problem so that the like terms are by each other. And notice we applied this property to subtraction also, being very mindful that the subtractions that are in front of these last terms stayed with those terms. The x is still negative, the y is still negative, and the 27 is still negative. And we can do that because subtraction is really the same thing as adding the opposite. The next step is the associative property of addition. Now I'm grouping these as to how they will combine together. And then we do some simplification. We did 23 minus 27, or you could call that subtraction. And then we're using the distributive property, but we're using the distributive property in reverse. We're taking that x and unmultiplying it from the 5x and the 1x. And the 7y and the minus y, we're taking the y and unmultiplying that, or dividing that out. Then we're simplifying again, we're subtracting again. 5 minus 1 is 4, 7 minus 1 is 6. And finally, we're using the commutative property of multiplication to rewrite x times 4 as 4x. Last example. Again, pause and try to justify each step. We start off with the distributive property. And then we're simplifying, we're multiplying, we're doing 3 times 2. Then we're using the commutative property of addition to change the order of the terms. Again, notice the 4x has a minus in front of it. That minus stays with the 4x. A sign goes with what's immediately following it. And then we're using the associative property of addition. The distributive property, we're undistributing though. Then we're simplifying. And finally, using the commutative property of multiplication to get negative x plus 6. And remember, you don't have to write a 1 as a coefficient unless you really want to. And that's the end of what we're doing today. It's a lot about identifying and being able to use these fairly simple properties, but remembering what they mean and how to apply them.